All right, so we have discussed about charging and discharging the capacitor in RC circuits. And today, or in this video, I will mention something that I have not mentioned in the previous videos so that we will reduce the confusion. So today, I am literally devoting this YouTube to talk about the voltage across the resistor in the charging process. I will recall this equation for the voltage of the charging process, which is increasing exponentially by this kind of curve. This is the voltage across the capacitor. So the voltage across the capacitor in the charging process is increasing in an exponential way, explained by the equation. The voltage across the capacitor is equal to the maximum voltage of the power supply, which is epsilon, times this exponential term, which is 1 minus exponential of minus t over tau. Great. So this is the charging process. This is the curve for the voltage across the capacitor in the charging process. What about the voltage across the resistor while the capacitor is being charged? Now, if we see if the voltage here is increasing, what should be the voltage here across the resistor? It should be decreasing. Why? Because this voltage has a voltage drop across the resistor and a voltage drop across the capacitor. So if one of them is increasing, the other should be decreasing. All right? Till the moment that, there will be anyway no voltage across the resistor because current will be zero. We have mentioned that before, that the moment we close the switch, the current will be the maximum, which will be VR divided by R. VR is the maximum at the moment we close the switch, which is epsilon over R. But while charging the process, let me write the equation in such a way, epsilon, which is the voltage, I will write it using Kirchhoff law. This is epsilon minus the voltage across the capacitor minus the voltage across the resistor is equal to 0. If we go through this loop, it is epsilon minus the voltage drop across the capacitor minus the voltage drop across the resistor. So the voltage drop across the resistor is equal to epsilon minus the voltage across the capacitor. We know very well the voltage across the capacitor in the charging process is epsilon times 1 minus exponential to the power minus t over tau. So you do the math, okay? We reach here that V across the resistor is epsilon minus this voltage across the capacitor, which is equal to all right, and we take epsilon as common factor, so we come across this equation, which looks like the discharging. If we go to the it's actually, I should not confuse you between discharging. This is not discharging. It is through the charging process. This is the voltage across the resistor, which is decreasing. It's decreasing, while the voltage across the capacitor is increasing. All right? All right, so this is important because the question could ask you, while charging the capacitor, find the voltage across the capacitor. So we will use this equation, all right? And it says, while charging the capacitor, find the voltage across the resistor. You keep in mind that while this is increasing, the voltage is increasing here, this is decreasing, all right? And you just need to know Kirchhoff rule on a closed loop that it is epsilon, the voltage drop across the capacitor, the voltage drop across the resistor. So if this is increasing, this is decreasing, and you don't really need to memorize anything. It's epsilon minus V across the capacitor, okay? And it's equal to epsilon exponential to the minus T over tau. I hope that I made it clear for so far. Now, let me just go through these notes. This is the PowerPoint that is in your Blackboard. Again, this is the charging process. So we started from 0, and this is the voltage across the capacitor. We started from 0, we increase all the way, it increased because it's charging. So when we are increasing, Q is equal CV. So if we are increasing the charge, so the voltage will be increasing, it's direct proportionality, till it reaches the maximum, which is the voltage of the battery, all right? And at T is equal to tau, we are reaching to 63% of the total voltage across the capacitor. Also, it is 63% of the total charge if we draw Q of the capacitor, and this is time. All right, so if you pay attention to this equation, voltage across the capacitor, we should write, is voltage maximum, which is the electromotive force, 1 minus E to the power T over tau. While the voltage across the resistor is decreasing, and we mentioned that it will be epsilon minus Vc. Why? From Kirchhoff rule, the voltage across the closed loop is the battery minus the voltage across the capacitor minus the voltage across the resistor, which is 0. So VR is equal epsilon minus Vc, which is epsilon minus epsilon times 1 minus exponential T over tau. We can take epsilon as a common factor. What we have, 1 minus 1, and then the minus goes there, plus epsilon E T minus tau. 1 goes with 1. So V across the resistor is equal to, did I do something wrong here? Yeah, I did something wrong. This is already out. It's here in the common factor. So it is just simply epsilon exponential T over tau minus. All right, now in the discharging process, be careful here. Be very careful actually. In the charging, we reach the maximum value of the voltage across the capacitor, which is the electromotive force. Now in the discharging process, you see they wrote V naught and they didn't write epsilon here. It could be E, but we don't care, okay? We do care that at the discharge, what was the voltage across the capacitor? We start from that voltage and then it will decay till it will reach almost to 0. So in the discharging process, we say the voltage across the capacitor, whatever the voltage across the capacitor, and it will decrease till it reach almost to 0. All right, guys? So what is the Q across the capacitor? Same thing, QC is equal C times V naught, okay? So it started from here and it goes. So this is a Q naught, which is the Q, whatever the charge that we start. It could be the maximum, but it could also be something else. So we started from V naught or Q naught. While in the discharging process, in the charging process, the maximum voltage that the capacitor will reach is the maximum voltage across the capacitor will be the electromotive force, and the Q 1 minute, the Q will be Q maximum. And what is the Q maximum? What is the maximum value of charge that we reach across the capacitor? It will be CV maximum, which is C times the electromotive force. While in the discharging, we start from the voltage across the capacitor. So what is the maximum, or what is the charge across the capacitor at that moment? It is CV, which is CV naught, the voltage across the capacitor. And in the discharge, at time equal to tau, what is the value that we will reach? We will reach to 37% of the initial voltage. And in the charge, we also reach to 37% of the initial charge. All right? And this is example. I think I solved something like that in the previous YouTube, so you can go through it. All right? And then here, I just want to mention here, we can go through this example very quickly, that this is not V times C, this is V sub C, so the voltage across the capacitor. From this equation, do you think, is this a charging or discharging? Let's see. A capacitor with initial potential difference, okay? So this is V naught. It means this is discharging. How I know that it's discharging? I don't know. This is the solution. I am reading here. He starts with a capacitor with initial potential difference. It means there is potential difference across the capacitor. It means Q is equal CV. So since we have an initial charge. Since we have initial potential, it means we have initial charge. It means, okay, now he's continuing. It is discharged through a resistor. You see the expression that the capacitor is discharged through a capacitor, through a resistor. If you see the picture here, we don't have a battery in the discharging process, because once we close the switch, basically current or charge will be moving, and the source of that will be the capacitor itself. The discharge will be from the capacitor. We don't have power supply anymore here. Okay, so V naught is known as discharged through a resistor when a switch between them is closed at t is equal to 0. So discharge start. At t is equal to 10 seconds, the potential difference across the capacitor is 1. All right. What is the time constant? Okay. What is the time constant of the circuit? So basically, what is missing? Time constant, tau. Tau is RC. But here, do we have R? No. Do we have C? No. So I cannot find the time constant by using my regular easy tau is equal RC. We have to form the equation, and we have to find the tau from this equation. All right? How to do that? I don't think so this YouTube will be enough to do this example. Hopefully we could do it in the classroom. Take care.